Hi everyone. Today we are going to discuss expansion using Maclaurin's series. If you know the expansion of f of x, that is, if we know the formula for f of x, then we have to find expansion of some standard function also. You know that very well, Maclaurin's series expansion of f of x, and this f of x can be written as fx is equal to. So what is the formula for fx is there? So this is f of 0 plus x into f dash of 0 plus x square upon 2 factorial into f double dash of 0 plus x cube upon 3 factorial into f triple dash of 0 plus and so on. There are infinitely many terms in this series here, so that is x raised to n upon n factorial into fn of 0. Also or I have to write the formula for this f of x, means f of x, it is a series of ascending powers of x, so that will becomes also, this is given as, this is a y of, or y is equal to, simply fx is equal to what? Y. And you know the formula for y can be written as, this is y of 0, means here y of 0 plus x into y1 of 0 plus x square divided by 2 factorial into y2 of 0 plus x square divided by 2 factorial into y2 of 0 plus and so on. There is n terms, so n up x raised to n upon n factorial into yn of 0. So this is Maclaurin series concept. This is Maclaurin series for f of x, and if we substitute here y is equal to what? F of x, then you have to getting the formula, that is generalized form of above formula is there, y is equal to, now in this way. Now let me start by using this expansion. By using this expansion, we have to find expansion of some standard function. Now let me start expansion of some standard function by using Maclaurin's series. So using the series expansion of some standard functions can be obtained. These expansion can be directly we use while you solving the problem. Now let us, I am writing here using the expansion of Maclaurin's series. So what is the Maclaurin series? I am writing the first, let Maclaurin series expansion for f of x in ascending powers of x, in ascending powers of x can be given as, the formula is there. So this is what the formula is: f of x is equal to f of 0 plus x into f dash of 0 plus x square upon 2 factorial into f double dash of 0 plus and so on, plus this is x raised to n upon n factorial into fn of 0 plus and so on. And also this can be written as, this is simply y is equal to 0, that is equal to y of 0 plus x into y1 of 0 plus x square upon 2 factorial into y2 of 0 plus and so on, plus x raised to n upon n factorial into yn of 0. So this is a expansion formula for Maclaurin's series. Now by using this formula you have to find the expansion of some standard function. Now let me start. Function number 1, expansion of sine x, or I will take here expansion of e to the power x. We call that is exponential form. Right? So e to the power x means it is nothing but it is a f of x, right? So I'm taking here, let's see, proof. Let y is equal to f of x is given to you, right? Means y is equal to here e to the power x. So simply if you have to write y of 0, so that implies y of 0, it is nothing but e to the power 0, and that is equal to, what is that here, 1. So this is y of 0. Now you know that now or yn is equal to, means if y is equal to e raised to x, then yn is equal to what, means it is nth derivative of d by dx raised to n of e to the power x. Nth derivative of e to the power x, it becomes e to the power x as it is, and we write here, so that implies yn of 0, it is nothing but again e to the power 0, and that is equal to 1. If you have to substitute in this formula, you will have to getting y1, y2, y3, right? Means that is, you will have to getting here, what is y1 of 0, y1 of 0, it is nothing but 1, y2 of 0, it is nothing but also 1, y3 of 0, this is also 1, and so on. Likewise, if we write yn of 0, that is equal to also 1. So by using now Maclaurin's series, so substituting this value in Maclaurin's series, I am writing here, substituting this value in Maclaurin's series. You know the Maclaurin's series is what? That is y is equal to, this will get y of 0, next term, that is x into y1 of 0 plus x square upon 2 factorial into y2 of 0 plus, and so on, plus x raised to n upon n factorial into yn of 0, and plus, and so on. There are infinitely many terms. So substituting these values, substituting y0, substituting y1 in this Maclaurin series, so you will have to getting that, you will have to getting that y means it is e to the power x, and that is equal to y of 0. You know very well y of 0, that is 1 plus x into y1 of 0, that is we get also 1, plus next y2 of 0, means here is x square divided by 2 factorial into y2 of 0, it will get also 1, plus next term is x cube divided by 3 factorial into 1, plus, and so on. If we write nth term, so x raised to n upon n factorial into 1. So this is a series expansion of e to the power x. This is a series expansion of e to the power x, and this can be done by using Maclaurin's series. This can be done by using Maclaurin's series. So once again I repeat it, you have to given suppose e to the power x, so we have to write y is equal to e to the power x, means y is nothing but function of x, and immediately you have to find, its nth derivative, and after finding the nth derivative, you have to substitute the values in this equation in Maclaurin series, and you will get the standard expansion. I hope understood all of this. Now I am going to discuss number second, that is expansion of cos x or expansion of sin x. Now for references, we call this is equation 1, means you know the now we are getting some result is there. So this series is known as, this is a series of exponential functions. Right, there are some remarks are there here. Okay, now let you know that very well. Let e to the power x is nothing but 1 plus x square upon 2 factorial plus x cube divided by 3 factorial plus, and so on. Now in this series we have to replace here. Now I am writing, there is a number 1 remarks is there, remarks. So what are the remark? Number 1, suppose let I am considering here replacing x by minus x in suppose series 1. I am writing here replacing x by minus x. So what you will be getting here, simply e to the power minus x, that is equal to, this will get 1 minus x. Now x square divided by 2 factorial means plus minus x square divided by 2 factorial plus minus x cube divided by 3 factorial plus and so on. There are infinitely many terms. So what will you have to getting here? So therefore e to the power minus x is equal to, this will get 1 minus x plus minus x square is nothing but it is a positive x square divided by 2 factorial plus there is a minus x cube, it becomes, what is that here, minus of x cube divided by 3 factorial. It will get minus of x cube divided by 3 factorial plus and so on. So you have to observe here, if e to the power x all terms are positive and if e to the power minus x all terms are alternate, plus minus sign is there. Now second remark, what is the second remark? Replacing x by ax, replacing x by ax. So if you have to replace x by ax, then what you will get in, or I am writing in equation 1 is there, in equation 1. So what will you have to getting here? Replacing x by ax. So this is equal to 1 plus ax plus a square x square divided by 2 factorial plus a cube x cube divided by 3 factorial plus and so on is there. So this is a series expansion of e to the power ax. Understood this? Now let me discuss here expansion of sine x. Let me discuss here expansion of sine x. So number second, expansion of sine x, or we called here in bracket sine series. Sine series. So let's see what is the sine series and what is expansion of sine x. Now if you have to given here y is equal to function of x, so let I am writing y is equal to what, f of x, and it is nothing but what is that here, sine x. You know the nth order derivative, already this concept we seen in successive differentiation. So therefore I am writing here, so that implies yn is nothing but it is the nth order derivative of dn upon dx raised to n of here sine x. And you know very clearly nth order derivative of sine x is what is that, that is a sine of x plus n into that pi divided by 2, sine of x plus n pi divided by 2, that is what, yn. Now I am taking here x is replaced as 0, so what is getting here, so y of 0. So y of 0 is nothing but, means it is clearly yn of 0, it is nothing but, means if we have to substitute x is 0, then it will get sine of n pi divided by 2, sine of n pi divided by 2, right? Now here putting same things we'll do here, n is equal to 1 2 3 4 and so on. So it will have to getting y1 of 0, it is nothing but sine of pi divided by 2, and sine pi by 2 you know that this will get here 1. y2 of 0, n is replaced as 1 2 3, so y2 of 0, that is a sine of pi, and you know the sine of pi, and sine of pi is value becomes 0, means sine 90 value is 0. If you have to substitute y3 of 0, so what is that here, sine of n is replaced as 3, so that will get 3 pi divided by 2. So sine of 3 pi divided by 2 means it is 3 times 90 degree, means it is a 270. Sine of 270, it will get minus 1. Also we have to substitute, suppose a y4 of 0, so that will get here sine of 4 pi divided by 2, so it will again sine pi by 2, and therefore this is equal to again 0. Also if you have to substitute here y5 of 0, it is nothing but it is a sine of 5 pi divided by 2, so it will becomes, means 5 times 90, so it will becomes here is 1, means here y1 is equal to 1, means y1 of 0 is equal to 1, y2 of 0 is equal to 0, y3 of 0 is equal to minus 1, y4 of 0 that is equal to 0, and y5 of 0 that is equal to 1. and so on. Means we have to take nth derivatives is here. Okay, so after that, substituting these equation or these values in Maclaurin series, substituting in Maclaurins series, we get you know very well what is a Maclaurin series. I am writing here y is equal to y of 0 plus x into y1 of 0 plus x square upon 2 factorial into y2 of 0 plus and so on. So therefore substituting this, y is equal to, you will have to getting here y of 0 means value is 1 plus y2 of 0 means I am writing here y of 0 that is equal to sine 0 and that is equal to value is 0. So let me correct here. So y of 0, it is nothing but 0 plus x into y1 of 0, it will get 1 plus x square upon 2 factorial into y2 of 0, it will becomes into 0 plus x cube upon 3 factorial into y3 of 0, that will again minus 1 plus x raised to 4 upon 4 factorial into y4 of 0, that is a 0 plus x raised to 5 upon 5 factorial into y5 of 0, that will becomes 1 plus and so on. So therefore clearly you will have to getting y is nothing but it is a sine x, right? Y means here is a sine x and that is equal to, the first term is what is that x plus second term is absent is there means into 0, third term minus x cube divided by 3 factorial, next x raised to 4 term absent, x raised to 5 plus x raised to 5 upon 5 factorial, next term x raised to 7 upon 7 factorial plus and so on. So this is a Maclaurin series expansion of sine x. This is a Maclaurin series expansion of sine x. We called this series is known as, this series is known as Sine series. Sine series. So in this way you have to expand sine x by using Maclaurin's series expansion. Understood this? Now let me start expansion of cos x. Here guys you have to very observe carefully here. Expansion of cos x. Cos x, it is nothing but it is a cosine series, right? It is a cosine series. So similar things we have to do here. First you have to take y is equal to what is given. Let I am writing here, let y is equal to here cos x. Y is equal to cos x. You tell me guys here y of 0. Y of 0 is what is that? That is a cos of 0, and cos of 0 you very well known, that is 1. Cos of 0 value is 1. Now I am writing its nth order derivative, means yn is nothing but dn upon dx raised to n of the term cos x. You know very easy, that is we have to find out nth derivative of cos x. So what is the formula for nth derivative of cos x? It is simply, that is a cos of x plus n pi divided by 2. Cos of x plus n pi divided by 2. This is a yn. And now I am writing here yn of 0. Yn of 0, it will becomes cos of n pi only. Cos of n pi only. And n pi divided by 2 is there. Cos of n pi divided by 2. Now putting your next target is putting n is equal to 1, 2, 3 and so on. So after substituting the values of n as 1, so we will have to getting y1 of 0. y1 of 0, it will becomes cos of pi divided by 2, and you know the cos of pi by 2, that is cos 90, its value is 0. Also y2 of 0, y2 of 0, it is cos of 2 pi divided by 2, so it will get cos pi, and cos pi value becomes cos pi, that is a minus 1, means cos 180 is a minus 1. If you have to substitute y3 of 0, it will get cos of 3 pi divided by 2, and cos of 3 pi divided by 2, it will becomes 0, it will becomes 0. And also suppose you have to write y4 of 0, that is equal to, that is a cos of 4 pi divided by 2, it will get cos of pi only, and cos of pi means I am writing here cos of 2 pi, and cos of 2 pi you know very well, that is equal to, what is that, 1, and so on. So substituting these values in Maclaurin's series, substituting these values in Maclaurin series expansion, Maclaurin series expansion, as you know very well Maclaurin series expansion. Now let's see what is the Maclaurin series expansion. Y is equal to, that is y of 0 plus x into y1 of 0 plus x square divided by 2 factorial into y2 of 0 plus, and so on. Now you have to write y is nothing but here is a cos x, and therefore y of 0, you know the value of y of 0 is 1, plus x into y1 of 0, that will get 0, so I am writing x into 0, plus minus x square divided by 2 into y2 of 0, means I am writing here x square divided by 2 factorial into y2 of 0, y2 of 0 you see here minus 1, y2 of 0 you see here minus 1, plus x cube divided by 3 factorial into y3 of 0, it will get y3 of 0, that is third derivative of y at x is equal to 0. So let's see y3 of 0, it will becomes also 0, plus x raised to 4 upon 4 factorial into y4 of 0, y4 of 0, it will get 1. So clearly, plus and so on, clearly the cos x is equal to, first term is 1 plus x into 0, the term is 0, minus x square divided by 2 factorial, next term is, what is that, plus x raised to 4 upon 4 factorial, next term is minus x raised to 6 upon 6 factorial, plus, and so on. This is a series expansion of cos x by using Maclaurin's series. This is series expansion of cos x by using Maclaurin's series. So this series is called as, cosine series. Cosine series. I hope you have to understanding this expansion of cos x very well. So you have to just put y is equal to given function, take nth order derivative, find the value of nth order derivative at a point x is equal to 0, and after substituting the values of n as a 2, 3, 4 and so on, means 1, 2, 3, 4 and so on, you have to find this value y1 of 0, y2 of 0, y3 of 0, y4 of 0 and so on. Substituting these values in Maclaurin series expansion, you will have to getting the respective expansion. That is in this discussion we have to prove expansion of cos x. Understood this? Let me start number 4 expansion of tan x. Let me start number 4 expansion, that is expansion of tan x. We called this is a tangent series. We call this is a tangent series. What is a tangent series is there? You know the tan ratio. In trigonometric famous ratio is a tan ratio. So how to prove this tangent series, or how to find out this tangent series? Let's see. Y is a tan x. After we are to taking derivatives, we get the equations as y is equal to here simply tan x. It's a first order derivative, it becomes y1, and y1 becomes sec square x, sec square x, and that is equal to, that is a 1 plus tan square x. It is a 1 plus tan square x. This is what? Sec square x. And again, you know that tan means what is that? Y. So y1 can be written as, this is a 1 plus y square. 1 plus y square. So now again we have to differentiate this y1 with respect to x. So we will have to getting y2 as, that is a d by dx of, I am writing here the term as now in this way, d by dx of 1 plus y square. You know that y square is a tan x, so it will get simply 2y into y1. So it will get simply 2y into y1, means one derivative is 0 plus y square derivative is a 2y, and y derivative again this will get y1. Similarly, you have to take here y3, and y3 taking as now in this way 2y into y1. So I am writing here, that is 2 into second into y derivative, it is a 2y1 square. So it will becomes 2y1 square plus 2y y2, 2y y2. Now if you have to take y4, y4 is taking as, this is a 4 y1 y2 plus 2y1 y2, 2y1 y2 plus 2y y1, 2y y1. There is a derivative we are to taking by using UV rule also here. After solving this y4, you will have to getting y4 as, y4 is nothing but it is a 2y y1 and 4y y2. It will get 6y1 y2. It will get 6y1 y2 plus 2y y1. This is y4. I am writing here y5. What about y5? What y5 is again 6y2 square plus 6y1 y3 plus 2y1 y3 plus 2y y4. This is just you have to take derivative of first into second plus second into first, means you have to use the derivative of here u into v rule, that is product rule. So it will take y5 as, that is a 6y2 square, 6y2 square plus 8y1 y3, 8y1 y3 plus 2y y4 plus 2y y4. So these are the successive differentiation of y up to y5, means it's a 5 time derivative is taken here. So now here I am writing what is y. Y is equal to suppose tan x, so I have to find out here y of 0. So let's see here, what is the y of 0? Y of 0, it is clearly tan of 0, and tan of 0 it is equal to 0. Let's see, suppose you have to find here y1 of 0, means put x is equal to 0 in this y1 y2 y3. So what we will get here, y1 of 0, it is nothing but that is a 1 plus tan square 0, that will get here 1 plus tan square 0, that will, it becomes 1. Y2 of 0, that is a 2y into y1 of 0. You will get y1 of 0 is 1 and y is 0, so therefore total answer is 0, means I am writing here 2y y1, means here 2 into y of 0 into y1 of 0. So what is that? 2 into y of 0 into y1 of 0. So this will get 2 into y0 is 0 into y1 of 0, that is equal to 1. So this will get total answer is also here 0. If you have to find out here y3 of 0, the formula is 2y square plus y2, means this can be written as a 2 into y square of 0. This will get 2 into 1 square plus 2 into y of 0 into y2 of 0. Y of 0 means it will get here 2 into 0 into 0, so that will get here 2. Similarly, we have to find y4 of 0. Y4 of 0, it becomes 6 into y1 y2, means y1 of 0, here y2 of 0 plus 2 into y of 0 into y1 of 0. So substitute the values is here, so this will get here 6 into y1 of 0, you see y1 of 0, so 6 into y1 of 0, that will get 1, y2 of 0, that will get here 0, plus 2 into y of 0, it will get 0, into y1 of 0, that will get here 1. So y4 of 0, clearly you will have to getting that y4 of 0, that is equal to 0. Next, y5 of 0. How to calculate this y5 of 0? Let's see. y5 of 0. So what is y5 of 0? y5 of 0, it is nothing but formula is 6y2 square, means 6 into y2 of 0, it's a square, plus 8 into y1 of 0 into y3 of 0, plus 2 into y of 0 and y4 of 0. So it will become 6 into y2 of 0, that will get is it is 0, plus 8 into y1 of 0, that is 1 into 2, plus here 0. So what will becomes here y5 of 0, that will becomes here 16. So guys, let's check here. y0, that is 0, y1 of 0 1, y2 of 0 0, y3 of 0 2, y4 of 0 0, y5 of 0 16. So by using these values and taking in a Maclaurin series, so what we will get, let's see. So I'm writing here, I'm writing here, what is y of 0? Y of 0 is equal to 0. Next, y1 of 0, that will get here 1. Next, y2 of 0, that will get here 0. y3 of 0, that will get here 2. y4 of 0, this is equal to 0, and y5 of 0, that will get here 16. So substituting in Maclaurin series, so what we will get here, Maclaurin series, you know that this is a y is equal to y of 0 plus x into y1 of 0 plus x square divided by 2 factorial into y2 of 0 plus x cube divided by 3 factorial into y3 of 0, plus and so on, so y is nothing but here I am considering here tan x. Y is nothing but here tan x, and tan x can be written as this is x plus this is y of 0. Y of 0, it will get here value is 0. y1 of 0 means here 0 plus x into 1 plus x square upon 2 factorial into y2 of 0, that will get 0, plus x cube upon 3 factorial into y3 of 0, that will becomes here 2, plus x raised to 4 upon 4 factorial into y4 of 0, that will get 0, plus x raised to 5 upon 5 factorial into y5 of 0, that will get here 16, plus and so on. So tan x is equal to 0 plus x, means it will get here tan x is equal to, first term is what is that here x, plus second term is 0, plus third term is what is that, that is x cube upon, that is only 3, plus x raised to 4 term is a 0, plus x5 upon 5 factorial into 16, so it will get 2x raised to 5 or 2x raised to 15 upon into 2. So I am writing here. Now what is after calculation, after finding the calculation, so this can be written as this is x raised to 5 divided by 5 factorial into what is that 16, plus and so on. So therefore tan x is equal to x plus x cube upon 3 plus 2x raised to 5 upon here 15, plus and so on. And this is a series expansion of tan x. This is series expansion of tan x. So this is known as tangent series of given function. Once again I repeat this, if you have to find out the expansion of tan x, so you have to find its a successively differentiation, and at x is equal to 0 you have to find its values. Now let's see if y of 0, y1 of 0, y2 of 0, y3 of 0, if we have to get once calculated, then substituting these values in the Maclaurin series, we have to getting that y is a tan x and getting the result as a tan x is equal to x plus x3 divided by 3 plus 2x raised to 5 upon 15. This is known as a tangent series. I hope you have to understanding this very well and enjoy this expansion of tan x. Thank you.